Hi, I'm William Yatman from Tech EFA department at ESA, and today I'll be presenting an overview of flat panel antennas for the ground segment. So in this presentation, I'll provide a review from ESA on what we see important trends for the flat panel antenna in the telecom ground segment. Here we'll focus a bit on the market and the future needs. I'll have a look at some of the achievements that we've seen within the ESA member states and also developments made outside the ESA member states. And then finally, I'll conclude a bit on what we see as the key points going forward. So first off, to talk a bit about the market, of course, flat panel antennas, they don't have a big share at the moment. As we can see on the graphs on the right, it's not a big market share yet. However, we see a big increase going forward, especially from the mid-2020s. We expect with the new constellations and new services that the flat panel will become more attractive. And we see, say, towards 2029, we expect that we'll have a more than 2 million units out in the market. This growth is mainly driven by the mobility market, which has limitations on size and form factor of the antenna. So we can't just attach a regular reflector antenna, which is normally used for SATCOM, but we really see a big benefit from the low profile of these. The flat panel technology revenue is both from equipment sales, but also new services that we expect to come. Some new opportunities emerging when this kind of antenna is readily available and cost effective in the market. This should also lead to spin-offs for other markets outside SATCOM. And one of the driving growth markets within mobility is commercial and governmental aero. So for aeronautics, they have a big need for these flat antennas, but we also see growth in the maritime and land, especially driven by new LEO and MEO constellations. So going forward, the market needs flat panel antennas. So we see an increased demand for SATCOM on the move. Everyone wants to be connected everywhere, on their train, on the bus, ships, aeroplanes, anywhere on the world. This leads to a good opportunity for the SATCOM and also for flat panels that we can easily integrate into all of these kinds of vehicles. LEO MEO constellations also see this as the key to their success. This could be mPOWER, Telesat, SpaceX, Amazon, OneWeb. There are a lot of opportunities coming here, and they need these flat panel antennas or active arrays with multi-beam capabilities. They could be orbit agnostic terminals so that we can switch between a LEO and MEO constellation seamlessly. Also, the modularity of this is a big driver and a big opportunity for these new constellations. Outside of SATCOM, we also see IoT, machine to machine, to be a big opportunity for flat panel antennas. Also, antennas you could wear. And of course, we also have the fixed consumer market. This is where we can see Starlink emerging now. Earth stations or gateways can also take advantage of this multi-beam capability, especially when they need to track several LEO satellites. So there are different markets that could benefit from this flat panel technology. Inside the ESA member states, we have in the last 5 to 10 years, we've seen a significant growth for this market. There's a lot of investment going on, both from ESA R&D projects to the industry investing in this. And we've seen a lot of companies emerge. So I put quite a few of them here on screen for you to see. A lot of these didn't exist previously. And this is across all value chains for the flat panel antenna. So both for the aperture they're developing, we have companies developing MMICs or RFICs, and also some of them making the whole complete terminal ready for the end user. This is exploring many different kinds of flat panel antenna technology. So we have phased arrays, we have some lens-based, we have liquid crystal. There's a lot of cutting-edge technology going on within the ESA member states. We also have investments from commercial satellite operators for the flat panel antennas. They have a great interest in this, and we've seen this by partnerships being established. So between OneWeb and SatixFy, for example, SES and Isotropic Systems, we see these partnerships coming up, leading to additional funding for the flat panel antennas. Also, companies that operate satellites and make their own terminals are investing heavily in the flat panel technology because they see this as a driving factor going forward. This could be SpaceX and Viasat. Just to mention a few success stories, we have, I'll start off with on the left for the unmanned aircrafts. We have Bernard Microsystems that have developed together with ESA this flat panel antenna to be mounted on the wing, and they have secured a contract for 12 aircrafts already. We have SatixFy with their IoT diamond terminal, and this the chips they develop, and this has a strong potential to take it outside IoT and transfer to other verticals such as space or SATCOM. Then we have Isotropic Systems, which has seen secured a lot of private funding. This has generated a lot of jobs and a lot of opportunities for highly skilled personnel developing these flat panel antennas. In this case, it's a lens-based system, so this is quite innovative. We have Atisat, that's already a player on the market, and they have several thousand units already installed across Europe. This is for land mobile and for fixed applications, receive only, so for TVRO, but already a player in the market. Viasat is investing. They've more than doubled their number of engineers developing these phased arrays, signing contracts with external customers already, and probably more coming forward. This is for the aeronautics, as we can see here on the picture. And then finally, we have RF Microtech that are developing a transmit receive active reflector array antenna. So another take on the flat panel for the user terminals. So there's a lot going on in the ESA member states, and we have a lot of success stories that new companies are emerging, new jobs are generated, and products are coming to market. Outside the ESA member states, we have some big competitors. So Kymeta already has their U8 Ku-band terminal out. This is a company that's had a lot of funding, and they're also expanding still. They recently acquired Lepton Global Solutions, and this will be a big competitor going forward. We have ThinCom that already have more than 1,500 of their antennas installed on commercial aircraft, showing the capability and that they can be used in the commercial way. This antenna has also been tested as an orbit agnostic antenna for GEO-MEO constellation, so we can switch seamlessly between them. This was done for the O3B. And ThinCom is also moving into other markets apart from the aeronautics. So they have started a collaboration with the US Navy to move this into maritime. And then finally, I'd like to highlight Starlink. So we have this new LEO constellation, and they make their own user terminal. This is a hybrid terminal, so we have both mechanical and electronic scanning. This means that we can do a core scanning with mechanics, and then the electronic scanning does the fine pointing and the fast switching, but it has a reduced requirement because of the mechanical steering in it. This antenna has more than 1,500 radiating elements, more than 700 RFICs, and so on. So it's quite a complex stack up, but it has a price of only $500. We've seen reports of up to 100 megabits per second of bandwidth on this system. So it's cheap, it's fast, there's low latency being LEO, and as Elon Musk says in his tweets, it's plug and play, easy to install. Nobody needs to have any training. So it's definitely a strong in a strong position in the market for fixed installations with this antenna. Just to mention a few others, we have Gillette that have their flat panel antenna in trials at the moment. You can see that on the right. We have NXTcom, Phaser, EM Solutions. They all have their phased array or flat panel antenna in the design phase. So we haven't seen a product yet, but they're moving forward here. And there's a lot of investment going on. We have new players coming to the market. Seacom, Infinitec, Greener Wave have all started recently and started development on flat panel antennas. And with all the development that has been done, these players are moving rapidly towards product. Then I'd like to talk a bit about the ESA member state and say our weaknesses and strengths we have here. So to start off with the negative, generally within the ESA member states, the TRL, so the technology maturity for the flat panel antenna is quite low. So there's quite a way to the market and to the end user. We also have a limited choice of ASIC foundries within the ESA member states. We have competitors outside having a large funding, government support. There's also evolution of the markets, so the terrestrial market can expand and take some away from the SATCOM industry. However, we also have some opportunities. So we see for the flat panel antenna, we have a lot of funding coming up. There's a lot of new activities going on with private investors or with ESA programs. So there's a lot of interest here. We can have some spin in from the 5G. There's a lot of development going on from this that can be transferred to the SATCOM industry, and we could take advantage of this. Within the ESA member states, there are a lot of technical expertise. We have a lot of as I said earlier, we have a lot of different companies now taking a lot of different approaches to this. So there's a lot of expertise that could take these next generation antennas forward, especially with the strong ecosystem we have with universities helping the R&D projects and the good balance between large and small enterprises, allowing us to investigate different things, cutting edge technology, and also take these to the market. So we think we have some strong potential within the ESA member states. Some key technologies for the flat panel antennas that we see going forward, how we can improve the competitiveness of this. One way could be to reduce the number of active elements. This could be by subarraying. A challenge here is to still keep the required RF performance for the SATCOM industry, but would reduce in cost save and reduce complexity. And then we have, say, RFIC design. This is a big point of active arrays, and we can here also exploit synergies with terrestrial. So 5G developments can be taken into this and vice versa. More new developments in ultra-high-speed ADCs and DACs will also be a big driver for flat panel antennas. And then we could also look into hybridizing, a bit like we see Starlink. So part electronic, part mechanical steering. This simplifies the design of the antenna and allows for a cheaper terminal. And then a big point going forward, we have to design to manufacture and design to test, because we look to open up for a volume market. So we had mass produce these antennas, and active flat panel antennas are not easy to test and verify. So it needs to be designed for this. So we cannot take an antenna apart and test every part of it. It has to be easy. It has to be able to be mass produced. Just to highlight a few of these, so on the reduction of active elements, we have an ARTIS activity starting this year with the objective to reduce the number of controls by 30%, making this a more competitive product for buses, trains, aero, this consumer market. Of course, we have to preserve the required RF performance, avoid grading lobes, and so on. So this is a bit of a challenge here. Then next year we have an ITT to be released with the objective to manufacture a hybrid mechanical and electronic scanning antenna for the user terminals, suitable for LEO systems. So here we have a goal to lower the complexity compared to a fully electronic scanning antenna, but still being able to operate on a LEO system. Also being able to be compatible with volume production. So here we're aiming for, say, a lower end, a lower cost terminal by hybridizing. So again, this is you can see this a bit in the Starlink antenna. And finally, to conclude, say the flat panel antenna is a key enabler of next generation SATCOM systems. So this should open up for new services and new markets within the mobility market. We where we see, in the mobility market where we see a lot of opportunities. ESA is an active partner in this flat panel antenna ecosystem, and in the last 5 years we've had a lot of investment within the ESA member states, growing growing the industry and attracting newcomers. This is creating new jobs, new companies, spin-offs to other segments, and so on, and also attracted more private investment. This again leads to us being able to develop cutting-edge technology and push this to the market. So just to finalize the challenge in going forward, the biggest challenge is the TRL level in the ESA member states has to be increased in all verticals. And this needs to be done so we can develop products to address the emerging markets. And also we need to increase the competitiveness of existing products. This could be by simplifying the antennas and making them more cost effective and so on. And this was all I had today. Thank you for listening. And if you have any questions, don't hesitate to contact me. Thank you.